Stand close enough to any fire and you can feel the radiant heat. But does the amount of heat vary depending on the size and type of fire? Do you feel different amounts of heat from a burning candle compared to a burning building? The heat produced by a fire can vary widely depending on the burning material, fuel load, available oxygen, and enclosure characteristics. You have likely heard your fellow firefighters talking about how hot a particular fire may have been. When you hear that, you may be thinking about the temperature of the fire. But the temperature of a diffusion flame burning in air is about the same regardless of the fuel. What really matters is how much heat energy the fire is releasing and how quickly it transfers to you. You may be thinking, isn't that determined by the temperature? Temperature is the average amount of heat energy contained in a substance. It is the heat release rate that represents the amount of heat energy produced by a burning substance. In short, the power output of the fire. Let's look at an example. If you burn one candle, the temperature of the flame is about 1500 degrees Fahrenheit. But what happens if you burn 10 candles? The temperature actually stays the same, about 1500 degrees Fahrenheit. Now let's look at the heat release rate. We measure heat release rate in watts, which is a unit of power. If you burn one candle, the heat release rate is approximately 80 watts. If you burn 10 candles at once, the heat release rate will be about 10 times greater, 800 watts. As you can see, the heat release rate better represents the size of the fire. The magnitude of the hazard increases when we start looking at typical household items. So we use the units kilowatts or megawatts to express the heat release rate. 1 kilowatt is equal to 1,000 watts. 1 megawatt is equal to 1 million watts. A small waste container on fire produces a heat release rate of about 30 kilowatts. A sofa can produce a heat release rate of 3 to 5 megawatts, and a king-size bed produces more than 4 megawatts. An upholstered chair fully involved in fire, with flames reaching 6 to 8 feet above the floor, is approximately a 2 megawatt fire. 2 megawatts are enough to flash over a residential-sized room, provided it has adequate ventilation. A typical training fuel load of 3 pallets and straw can reach a peak heat release rate of 2 megawatts. But in the training environment, this fuel load will not flash over the fire room because of the non-combustible construction of the training building, lack of other fuels, and limits on ventilation. We know that most residential spaces will not only have the single upholstered chair, but will also have carpeting, a sectional or a sofa, and more. We refer to the total quantity of combustible material in the space as the fuel load. The fuel load represents potential energy and has a significant impact on the fire. Understanding how the heat release rate impacts the thermal conditions of a room, ignition of nearby fuels, and heat transfer to you is important to understanding the hazard on the fire ground.